Have you ever wondered why we age? Why does time leave its mark on every living creature? It's a question that has puzzled scientists and philosophers alike for centuries. But as we delve into the biology of aging, we realize that it's not just the relentless march of time that causes our bodies to change. No, the story of aging is far more complex and fascinating. In the grand tapestry of life, every organism, from the tiniest microbes to the most majestic blue whales, all share a common experience: aging. Whether you're a delicate butterfly fluttering for just a few short weeks, or a colossal sequoia standing tall for thousands of years, life is a journey through time that no creature can escape. But what is aging, really? Is it simply the passing of days, months and years? Or is there more to this universal phenomenon? The answer lies deep within our biology. You see, aging isn't just about the ticking of the clock. Rather, it's a series of biological processes, an intricate dance of life and death happening inside us at every moment. From the moment we are conceived, our bodies are in a constant state of change. Cells divide, tissues grow, and organs develop. As the years pass, these processes continue, but in a different manner. Cells lose their vitality, tissues begin to wear, and organs don't function as efficiently as they once did. This is the biological face of aging, the subtle transformation that happens within us as we journey through life. But why does this happen? Why don't our bodies simply keep renewing and repairing themselves indefinitely? Why must we age? These are the questions that have fueled scientific research for decades. And while we're still unraveling the full mystery, we've made some fascinating discoveries. So, if aging is more than just the ticking of the clock, what exactly happens inside us as we grow older? To understand that, we'll need to delve deeper into the building blocks of life, into the heart of our cells. Let's take this journey together into the fascinating world of the biology of aging. The secret to understanding aging lies in our cells, the smallest units of life. These microscopic entities are the very foundation of our existence, the building blocks that construct every part of us. Each cell is a bustling metropolis of activity, with countless processes happening every moment. And just like any city, cells age over time. Now let's dive a little deeper. Our cells are constantly renewing themselves, a process that keeps us healthy and functioning. This process of renewal is largely dependent on the cell's ability to divide and replicate. At the heart of this cellular division are the telomeres. Think of them as the plastic caps at the end of your shoelaces. These telomeres protect our genetic data, making it possible for cells to divide. However, each time a cell divides, the telomeres get a little shorter. When they become too short, the cell can no longer divide, and it becomes senescent or aged. Cellular senescence is the state of a cell when it can no longer divide and renew itself. This is a natural part of the aging process, but it's not without its consequences. As more and more cells reach this state and lose their ability to regenerate, we start to see the physical manifestation of aging. Our skin loses its elasticity, our hair turns grey, and we may find ourselves not quite as spry as we once were. This process, while completely natural, can be accelerated by factors such as stress, poor diet, and lack of exercise. But the story of cellular aging doesn't end with senescence. There's a whole world of research exploring how we can influence this process, potentially slowing down or even reversing the effects of aging. It's a fascinating field, filled with potential for improving human health and longevity. So, as our cells age, so do we. But what triggers this cellular aging process? Our DNA, the blueprint of life, holds the key to our aging process. At the heart of every living cell, DNA, or deoxyribonucleic acid, is hard at work. It's the architect of our bodies, directing the construction of proteins, the building blocks of life. But even the most meticulous architect can make mistakes. During DNA replication, errors can occur, leading to damaged DNA. These errors, or mutations, if left unrepaired, can cause our cells to function less efficiently, leading to the gradual decline we know as aging. But how does DNA get damaged in the first place? Well, it's not just errors during replication. External factors like radiation and toxins can also wreak havoc on our DNA. Picture a beautiful, intricate sandcastle on the beach. Now imagine a gusty wind or a rogue wave. That's what radiation and toxins can do to our DNA. They can cause breaks in the DNA strands, distort its shape, or even change the sequence of the DNA building blocks, the nucleotides. But it's not all doom and gloom. Our bodies have a remarkable ability to repair DNA damage. It's like having a team of skilled builders constantly on standby, ready to mend any cracks or breaks in the DNA structure. They can remove damaged parts and replace them with new, undamaged ones. They can even fix the sequence of the nucleotides, restoring the original DNA blueprint. However, as we age, this repair mechanism becomes less efficient. It's like the builders are getting tired, and they start missing some of the damage. Over time, the accumulation of these unrepaired DNA damages can cause cells to age faster. It's a bit like a house that's not maintained properly. The more damage it sustains, the quicker it ages. Our cells' ability to repair DNA damage declines as we age, speeding up the aging process. But how does this cellular aging translate into physical signs of aging? The aging of our cells doesn't just stay hidden under the microscope, it manifests in ways we all recognize. The physical signs of aging are a testament to the changes happening at a cellular level. The wrinkles that etch our faces over time, for instance, are a result of cells gradually losing their elasticity. The collagen and elastin that once gave our skin its plump, youthful appearance begin to break down, causing our skin to sag and wrinkle. Then there's our hair. Remember when it used to be full and vibrant? As we age, the pigment-producing cells in our hair follicles begin to die off. When there are fewer of these cells, our hair turns grey and eventually white. This isn't just a cosmetic change, it's a cellular one. And it's not just our skin and hair, our vision and hearing, our muscle strength and bone density, our memory and cognitive function. All these facets of our being are subject to the effects of cellular aging. As cells age, they function less efficiently. And the cumulative effect of this inefficiency impacts the function of our tissues and organs. Our eyes, for example, are composed of millions of cells, each with its own job to do. As these cells age, they become less effective at their jobs, which can lead to conditions like age-related macular degeneration or cataracts. Similarly, our bones are constantly being broken down and rebuilt by cells called osteoclasts and osteoblasts. But as we age, this process becomes less balanced. The osteoclasts start to outpace the osteoblasts, leading to a decrease in bone density and an increased risk of fractures. So you see, the aging process isn't just skin deep. It's a complex, multifaceted process that happens at a cellular level and affects every part of our bodies. It's a testament to the intricate and delicate balance of life itself. Aging, then, is a complex interplay of cellular processes, but can we do anything to slow it down? The prospect of slowing down aging has fascinated humans for centuries. Indeed, the allure of youth and longevity is a tale as old as time itself. Today, we find ourselves on the cutting edge of science, with research delving into the very fabric of our existence in an attempt to slow down the hands of time. Current research into aging is as diverse as it is promising. Lifestyle changes, for instance, have shown significant potential. Regular exercise, a balanced diet, adequate sleep, and stress management are not just buzzwords. These are scientifically backed strategies that promote healthy aging by reducing cellular damage and improving overall health. Moreover, the field of medical intervention is thriving. Scientists are exploring the potential of drugs that target aging at a cellular level. These include senolytics, which seek to eliminate senescent cells, the worn-out cells that contribute to aging. And then there's metformin, a common diabetes drug, which some researchers believe could potentially extend lifespan. However, it's vital to approach these developments with a healthy dose of skepticism. The landscape of anti-aging interventions is rife with false promises and quick fixes, products that do more harm than good. It's important to remember that aging is a complex process, one that cannot be halted with a single pill or procedure. Above all, the aim should not merely be to extend life, but to enhance its quality. The concept of health span, that is, living not just longer but healthier, is gaining more recognition. After all, what's the point of a long life if it's not a life well lived? Finally, it's worth noting that our understanding of aging, while constantly evolving, is still incomplete. We're in the midst of an exciting journey of discovery, unraveling the mysteries that have perplexed humanity for ages. While we may not yet have the secret to eternal youth, understanding the biology of aging gives us a clearer picture of why we grow old, and perhaps how to do it gracefully.